Hey everyone, in this video I'll be showing you how to analyze data for calibrations in the Netzsch STA. So first thing I'll do is open up one of the correction files. In this case I'll actually open up a couple just to show you a couple different cases. So I'll just select a few of these. And I will load those into Proteus Analysis. First thing I'll do is change the x-axis from time to temperature, and I'll hide the isothermal segments. Then I'll turn off the beginning segments in which I'm just ramping up the temperature but doesn't actually contain the data, or the segments in this case in which I'm reaching higher temperatures to burn off the remainder of the sample. I'll then turn off any TG signals or additional signals that I won't need for this. You'll only need to be looking at the DSC signals for this analysis. And now you can see I have isolated the 3 DSC signals for the 3 compounds I'm evaluating in this video. So what I'll do is I'll zoom in to a particular transition of interest. And I'll generally try to keep the zoom pretty tight around the actual transition so that I can get a good view of it. To analyze this, we need to find the total area of this transition, the area under the curve, and the extrapolated onset temperature. To do this, you can right-click on the DSC curve, go to Evaluate, and Complex Peak. You'll get this menu along the top. You can adjust the temperatures that you're going to evaluate over, both the left and the right. You can change what values you want to be computed. In this case, again, we want to compute the onset temperature and the area under the curve. You can also select what type of baseline to use when calculating the area and onset temperatures. In terms of actually selecting the region of temperatures, you will want the left region to be just before any type of onset and the right region to be just after the transition is completed. In this case, we'll look at when this curve starts to dip below what we would consider would happen without the transition occurring, and when it's reached a stable state and is constant. There's a couple different baselines you may want to choose, and I'll show you what they look like. If I do the tangential baseline, that will compute a tangent to the curve at the beginning, a tangent to a curve at the end region, and then interpolate between them. If I choose something like the linear baseline, that will just draw a straight line for my beginning and end temperatures. You may want to use, in some cases, different types of baselines. The bezier can be an appropriate one in some circumstances, but generally I'll stick to either the linear or the tangential. I would choose the tangential baseline whenever there is a change in heat capacity across the transition. So in this case, you can see that we're continuing along a certain trend here, and then that slope of that line changes after the transition. So I would find it most appropriate to use a tangential baseline. You can click OK, and then you can see that we computed the area under this curve and the onset temperature. I'll go ahead and show you this now for another one of the calibration compounds. Again, I'll right-click on the curve, go to Evaluate, Complex Peak. I'll choose a temperature range right before any transition and right after the transition is completed. In this case, it would actually be potentially appropriate to choose a linear baseline as opposed to a tangential. As you can see, we have pretty much a straight line across that. And now you can see the computed area and onset temperatures. One question you may have is exactly where to place these left and right ones. And I've said before and after the transition, but that can be somewhat subjective to different operators. You'll notice that the onset temperature, if I were to move this, is not very sensitive. placement of these cursors. However, the area can be somewhat sensitive, but is very minor relatively. You can see if I move it way over here, I get an area 583, whereas if I move it closer to transition, it's 580. So not much difference. Finally, I'll do the last one. This one can be a bit trickier because you have evaporation and decomposition occurring at the same time that you're getting the melting transition. But we'll go ahead and do a complex peak. Pick a temperature before and after any transition. Here I'll show you what some of the different baselines look like. In this case, I'm using a linear baseline. I'll select the Bezier baseline. You can see that one allows it to curve a little bit more, which in this case I actually find more appropriate because you are having this period of dynamic heating that's not quite at a constant heating rate. So a curve is a little more appropriate to model that. You can see if I were to choose a linear model, it's a little lower. So it's your choice which one you choose. I would recommend the Bezier or the tangential in this case. And then you can see our area and onset temperatures are calculated. These are the values that you would then take to your sensitivity program. So I can open that up. I'll create a new calibration at a heating rate of 10 Kelvin a minute. And I can see, so for this substance, this is potassium chromate. So I would go to that substance in the chart, potassium chromate, the temperature at which that transition happens, and the enthalpy is here. And then for the sensitivity, I would fill in the peak area, which you can see is in the units of microvolt second per milligram, the same as the computed area here. So in this case, we would enter negative 102.91. Now I'll show you what to do in the temperature calibration program. It'll be more or less the same procedure. I'll go ahead and quickly create a new one. And then I can go down to potassium chromate, and we'll have the nominal temperature, which is the reference value. In the experimental, we would fill in with our test here. So in this case, 675.1. You would complete this for all of the relevant substances at which you've conducted the calibration on. And then you can click to calculate either a linear or a quadratic approximation for this, or in the case of sensitivity, it's just a single calibration. If you aren't using any of these substances, you may click on it and click delete to remove them from the list. Well, that's how to compute the onset temperatures and areas for your calibration files in Proteus Analysis. Hope that was helpful, and see you in the next video.